What up, calculus students? Mr. Messner coming at you. We're going to practice finding the equations of m's, slope equations for functions. It's a brilliant discovery. Newton took the limit, took the slope formula. This is Newton's slope formula. He took the slope formula, he took the limit, he married them, he discovered that they created equations. And he took very generic forms, plugged it in here, and created rules. Okay, so we are going to learn rules, F prime rules, so that you understand the equation of the slopes. The first rule is called the power rule. And the power rule says if you take x to the n and you plug it into there, and that's your function, that its slopes are going to be n times x to the n minus 1. It's just a very simple thing. You take your power, you move it down, and you subtract 1 from the power. Okay? Now, let's remember, plug in x's into f, get y's. Plug in x's into f prime, get slopes of tangents. Get f prime values are slopes of tangents, which are instantaneous rates of change of the function. Now, some things that we have to worry about. Powers in the denominator, fractional powers. All things we have to worry about. What we want to do, maybe before even taking the derivative, is rewriting things. I'll write this as an x to the negative first power. I'll write this as x to the negative second power. And I'll write this as x to the negative third power. The power rule doesn't work in a denominator, so make sure you have that. Next thing is the power rule doesn't work with roots. Like there's no root rule. Instead, you write this as a fractional power. All right, so when you take the derivative, move the power down, subtract 1. Move the power down, subtract 1. Move the power down, subtract 1. X, everybody messes up on these for at least once. Like x, y equals x is a straight line, looks like this. Its slopes are always 1. You can use the power rule with this and take the 1, bring it down and subtract 1, and it's 1x to the 0. X to the 0 is 1. I like to just think the slopes and keep in mind all we're doing is looking at the slopes. The slope of x's are 1. The slope of y equals 1 is 0. So that goes to that. This goes to this. Now, with negative powers, be careful. When you subtract 1, it becomes more negative. So it's negative 1x to the negative 2, negative 2x to the negative 3, and negative 3x to the negative 4. Now, this is great and all, but what are we going to use this for? There's multiple things we're going to use these f prime equations for. Don't forget, you plug in x's and you'll get m's. You will get f prime equations and you will set your f prime equation equal to a slope that you're looking for, and you'll find x's. If f prime equals an m, you can find an x that equals a certain m. So make sure we understand that. That's the most important thing about this whole semester is we are going to analyze how f is changing. To analyze how f is changing, we're actually going to look at its slope formula. And analyzing the slopes will tell me how f is changing. I'll be able to graph f without using a graphing calculator. I'll be able to find interesting points on f without using a calculator, all that. The first thing we want you to do is actually find a value. So I want you to find f prime of 1, and I'm asking you what they represent. Again, f prime with an x gives me an m. This is a slope of a tangent, that kind of m, which gives you the instantaneous rate of change of the function at a point, which is what we use the word derivative for. It's synonymous. So if I plug in 1, I get 4 plus 3 plus 2, 4, 5. Actually, let's just do the minuses. Sometimes we need negative power. Sometimes it doesn't help us to plug in. Making sure we understand that a negative power, the negative one's going to stay. The x to the negative second is going to move. The negative 2 is going to stay. It's not taken to the power. Leave the negative 2, move the x to the negative third. So anyways, like when I plug in 1, I'm just going to get negative 1. When I plug in 1, I'm going to get negative 2. When I plug in 1, I'm going to get negative 3. So I'll just write it down. I got 4 plus 3 plus 2 plus 1, minus 1, minus 2, minus 3. So the 3s, the 2s, the 1s gone, I get 4. All right, so f prime of 1 is 4. At x equals 1, f of x increases 4 y's per x. Instant rate of change. If we have a number in front, it's not that the slopes of 4 are 0 and we need to take that into account. We just leave it. Okay, this will be important in the future when we're talking about sines and cosines. Bring down the number, I get 12x squared plus 6x to the first plus slopes of y equals 2x or 2. Slopes of y equals 5 are 0. Slopes of x to the 1/3 will be 1/3 x to the. Subtract 3/3 from 1/3. You get negative 2/3. If you are not doing this yourself and you're just watching and copying this video, you're not helping yourself out. We got negative 2x to the negative first. I like to distribute negatives whenever possible. I got negative 3x to the negative second. So using the power rule here, I'll get positive 2x to the negative second. I'll get positive 6x to the negative third. If you'd like to rewrite these so that you can plug in values easier, sometimes we need negative exponents to take a derivative. We don't want negative exponents to plug in values. I'm asked to find y prime of 1, so I'm going to plug in 1 as well into this. I get 12 plus 6 plus 2. I mean, this is like incredible that we are able to easily find the slope of a tangent to this very complicated function very easily. Thank you, Isaac Newton. This is 1 over 3x to the 2/3. You need to know how to plug in values other than just 1 into that. You have to know how to plug in 8 into a 2/3 power. I think we'll do that for the next one. No, I think we're just plugging in 1 for that one. Hopefully we have some examples where you're plugging in numbers into the 2/3 power. So, yeah, that's a third. This is 2, this is 6, and they're all positive. So I get 12, 18, 20, 22, 28, 28 plus a third. This weird sound. 84 thirds. 85 thirds. At x equals 1, y is increasing 85 thirds y's per x. It is the slope of a tangent. It is the instantaneous rate of change. It is the derivative of this function at 1. Okay. I think the reason why I put this one here is so that we know when you subtract 1, you got to subtract different kinds of 1s. So this is subtracting 4/4. This will be subtracting 3/3. This will be subtracting 2/2. Getting us that. It's a 4th root, cube root, half root. Like, that's important to know that a 1/3 power is just a cube root. I am just plugging in 1 into this, so I got 5/4 plus 4/3 plus 3/2. I will be asking you to take like 8 to the 1/3, 8 to the 2/3. You need to be able to do that. Oh, I need a common denominator, so I'm going to multiply this by 3. I'm going to multiply this by 4. And this by 6. 31, 43. At x equals 1, h is increasing 43/12 y's per x. This is the slope of the tangent. This is the instantaneous rate of change. This is telling me what my function is doing. It's going up. It's going up quickly. All right. Derivative rules. If f is sine, its slopes, math works in mysterious ways sometimes, it's cosine. Crazy. The slopes of sine are cosine values. If f is cosine, the slopes are actually negative sine. This is like the one that people get tripped up on. So, heads up. Okay. If we take the derivative of 3 cosine, what's important is that 3 is just a constant. It's not bothering anything. Just leave it. You don't take the derivative of 3 and say it's 0. You leave the 3. The derivative of cosine is negative sine, so I get negative 3 sine. The derivative of positive sine is positive cosine. The derivative of negative sine will be negative cosine. So like whatever you want to do, either leave the minus or just put the cosine. If you see something like this, make sure you rewrite it. This is x squared to the 1/5, which means it's x to the 2/5. If you were to take the derivative of this, bring the 2/5 down, subtract 5/5, you get negative 3/5, giving me this. Okay? Leave the 2 up, leave the 5 down, move the x to the negative 3/5 down. Plugging in pi. The sine of pi is 0, so that's gone. The cosine of pi, I need to know. Cosine of pi is over there. So 0 pi. Since pi is over there, I'm going to the left one. The cosine of pi is negative 1. So this will be a positive 1. Now here's the first instance of getting a value, being like, what do I do now, Mr. Messner? And I'm just going to tell you nothing. This is your slope. It's going to be 1 plus some fraction. Exactly what that equals, we don't know because we have to take pi to the 3/5. It's fine. Sometimes we're just going to have funky answers and we're just going to leave them, but they are the right answer. Okay? I'm just going to draw a line down there so I don't have to rewrite it. At x equals pi, g is increasing 1 plus 2 over 5 pi to the 3/5 y's per x. All right, the next one's good. I probably want to do it without the x squared, but leave the 3. Derivative of sine is cosine. Derivative of cosine, negative sine. Plugging in pi over 4. Cosine of pi over 4 is root 2 over 2. Sine of pi over 4 is root 2 over 2 as well. So I got negative root 2 over 2. And then I got minus 2 pi over 4, which is a pi over 2. Okay, that's nice. Here's one thing I could do. You might be required to do this on a multiple choice. Unsimplified answers, totally fine for free response, totally fine for your quiz. Simplified free response, probably required for multiple choice. Like you're going to have to find an answer choice. You're going to get an answer. You're going to need to simplify it. Now, here's what I have. 3 root 2 over 2's. You can take that 3 and multiply it in. So it's 3 root 2 over 2. minus a root 2 over 2 minus a pi over 2. I can combine the root 2's to give me 2 root 2's, subtracting the pi over 2. Now you could write this also as root 2 minus pi over 2. That's fine. There's different ways to do this. Probably looking for this as being your answer, which gets a common denominator. When you have a common denominator, you can just add or subtract your numerators. Again, these are tricky, but not designed to like trip you up. Besides, make sure you understand the power rule, how to use it, how to plug in values. If you get a complicated answer, maybe you're just going to leave it. All right. For those, I asked you to find the slopes of the tangent. I just wanted you to find m. Moving forward, now I'm asking you for equations of tangent lines. Now you got to remember that you need more than just a slope to find an equation of a line. You need an x and a y and an m. Okay, let's remember. Plug in x's, get y's into functions. Plug in x's, get m's into derivative slope equations. Finding the slope equations is very easy to do. Using them is and understanding them, the important part of this class. So I can plug in 1. This is going to be 1. I can plug in 1 into this y. Now, some housekeeping, which means keeping things orderly, I would say y of 1. Okay, that means I'm plugging in 1 for x. I get 1 plus 2, which is 3 minus 3 is just 0. Okay, next thing is I'm going to get my y prime equation, my slope equation for y. It's 2x plus 2. I will plug in 1 to get 4. Now again, x, y, x, slope of y at that x, slope of the tangent. Y minus 0 equals 4x minus 1. Totally fine for this on free response. Most likely on multiple choice, they might have y solved for and put into y equals mx plus b form. Cool. All right, so remembering this is what I need, I'm just going to kind of plow through these. F prime is negative sine. F of pi over 3, the cosine of pi over 3 is a half. That is my x, y on my equation. Plugging in pi over 3, this is my x, m. Sine of pi over 3 is root 3 over 2, so I get negative root 3 over 2. That is how quickly cosine is changing at pi over 3. Y minus a half equals negative root 3 over 2, x minus pi over 3. Maybe you add the half over, probably wouldn't distribute everything. This is probably fine for multiple choice even, because once you start distributing, it's not going to make it easier. All right. Y of negative 2. Again, negative 8 times negative 3, which is positive 24, plus I get 2/4, which is 1/2. So I get 48 halves plus 1/2 is 49 halves. Cool. Let's find the derivative. To find the derivative, you need to get rid of that x in the power in the denominator. X in the denominator is bad. Power rule likes powers in the numerator. I get y prime equals negative 9x squared plus negative 4x to the negative third. Cool. Plugging in negative 2, I get negative 36. I need to be able to plug in negative 2 into a negative third power. I go back to plug in. I need that positive third power. Again, leave the negative 4. It's not bothering anything. Move the x to the power. Plugging in negative 2 gives me negative 8, which means this gives me 1/2. Negative 4 over negative 8. 72 halves plus a half is 71 halves. They're negative. Negative 72 halves plus a half. It's negative 71 halves. X, Y, X, and M. Y minus 49 halves equals negative 71 halves X plus 2. I'm leaving it. Once again, make sure you rewrite this as X to the negative first. 3, let's plug in 3 first. I'm giving you all these with like fractions just so like when you see them in the future, you don't make mistakes on them. Give you more of like the tricky ones than the easier ones. So the easy ones are important. 8. Okay, XY. Let's find your slope equation. 3 plus 3 over x squared. Now, why do I get that? I move the negative 1 down. I get positive 3 times x to the negative second. So this becomes positive 3x to the negative second. Leave the 3, move the x's. Plugging in 3, we get 3 plus 3 ninths. 3 ninths is the same as 1/3, so it's 3 plus a third. So it's 9 thirds plus a third, which is 10 thirds. For your quiz, again, X, Y, X, M. For your quiz, I would simplify this. Watch this. Y minus 8 equals 10 thirds X minus 10. Add 8. Y equals 10 thirds X minus 2. This is what you're probably going to want for your test. Be able to solve for Y for your test. This is what we want for our quizzes, for the free response questions we're going to see in the future. That. All right. Plugging in X gets M's. Sometimes we want to understand when or what X's, which we don't know, will our slopes equal 12. If we have a slope generating equation, if we have a slope equation, we can find what X coordinates will produce certain slopes. When will the slopes of X cubed equal 12? Oh, okay. Well, the slopes of X cubed are given by 3x squared. Those are slopes. When will my slopes equal 12? And we're going to find answers for X. Finding X coordinates, set up equations. Equation with X's equals a slope. Solve for X. Boom, you'll find the locations. Both positive and negative 2. Done. Cool things, we can find locations of the functions that have certain slopes. What X coordinate location does this increase at a rate of 16 y's per X? That's just a slope. When will this equation produce a value of 16? When will my slope generating equation generate a certain slope? Add 6, divide by 2, boom, at X equals 11. Where do we have horizontal tangents? Okay, first things first, what would a horizontal tangent look like? It would look like this. What would be its slope? The slope would be 0. When will this slope equation produce a slope of 0? Boom, X equals 9 halves. This is fun. This is like, it's not fun. It's fun for me. What did you just find? You just found the location of the vertex of this quadratic. Like x squared minus 9x minus 10. Boom. Horizontal tangent would occur at the vertex at this minimum location. So we just found the vertex using calculus. If you remember from Algebra 1, the quadratic formula, you could do the opposite of b over 2a, the opposite of b over 2 times a. And that's how you find the x-coordinate of the vertex. What you never learned in previous math classes is how to find the locations of the humps of a cubic. This is a cubic function, so it's got, a couple turns here. How do you know these locations? Calculus helps because these will be locations of horizontal tangents where slopes are 0. So this is like a cool thing we start to see, like the magic of the slope equation. You're going to be able to understand cool characteristics of functions without having a graphing calculator. Understanding calculus was the first graphing calculator. I get x squared plus 5x plus 6 is my slope equation. Well, my slopes equal 0. This is my favorite quadratic that can factor and solve. All right. Same deal. When will my slope equal -1? Okay. When will my slopes at what locations? Where will my slopes equal -1? Don't factor until you have an equation set equal to 0. I'm going to add 1 to both sides. Going to factor out a 3. I'm going to factor this. Boom. When x is -3 or x is -1, my slope of my tangent will be -1. Other cool things we can see where we have, it's just more questions of like where we see we have particular slopes. We have these parallel questions. When, and hold the thought, we want this equation. Find the equation of the line tangent to this that's parallel to this. And this is great because I'm going to be able to show you the work that we do. Now, first things first, we understand from previous math class, parallel lines, the slopes are the same. Parallel lines equal slopes. The slope of this, you do not need calculus to know. If you solve for y, you get y equals mx plus b. Now, you could take the derivative of this and say that the slope is 6. You can say y prime is 6 if you wanted to. Okay. The slopes of this will come from 2x minus 6. Okay. When will these slopes produce a slope of 6? That's when we're going to have parallel lines. So I get this equation, 2x minus 6. When will that produce a slope of 6? Set up an equation, add 6 divided by 2. X equals 6. Okay, cool. That is an x-coordinate location, but we want an equation of a line. So back up. Let's remember that my goal is not just an m, not just an x, but an x, a y, and an m. Well, I have the x. If I plugged in that x, we know we would get this slope of 6. That's what we spend all the time finding, that the slope is 6. So I have an x. I don't like that the m is the same value, but it happens sometimes. All I need is the y. This is the m of 6. This is the x of 6. What is the y? How do I find a y? I need an equation where if I plug in x's, I get y's. Oh yeah, my original equation. Plug in x's, get y's. 36 minus 36 plus 2 is 2. Boom. Okay? I'm going to show off because it's fun and because I have Desmos up. Y equals x squared minus 6x plus 2. Looks like that. Y equals 6x plus 3. Looks like that. This is not a tangent line. This line is not tangent to this. But this line is easily solved for y. Y equals 6, x minus 6, plus 2. will be tangent to my quadratic and parallel to this line. This is like the stuff that is beautifully seen. You don't see it, you don't appreciate it as much. Here's my function. Here's its tangent line that is parallel to this random line. I think it's nuts. Here, the slope is 16 of this line. When will this equation produce a slope of 16? Okay, well, when will the tangent slopes produce a tangent slope of 16? Subtract 4, divide by 3, square root, don't forget your plus or minus. There's two lines. I got a y minus y1 equals, I'm going to get a slope of 16 at both positive 2 and negative 2. Okay, so I'm plugging in those x's. I need the y's, plug in x's into your original equations to get y, plug in x's into your derivative equations to get m's. Here's the m that I got for these x's. Double check if you want to. Plugging in 2, 8 plus 8 is 16 plus 1 is 17. Plugging in negative 2, I get negative 8 plus negative 8 plus 1, so that's negative 15. Cool. I'm going to leave it at that. When do these have the same rate of change? At what x locations? When does this equation slopes equal this equation slopes? When will the slopes equal? Set up an equation, solve. Variables on both sides. Don't be worried. I get negative 3/4. Now let's look at that for fun. At x equals negative 3/4. Zoom in, zoom in, zoom in, zoom in. The slopes will equal the same. You can sketch or find the slopes at negative 3/4. The slopes will be 3/2 in both locations. Positive 3/2 y's per x. That's cool. Maybe tough to see, but we got it. Same here. When will this equation's tangent slopes equal this equation's tangent slopes? Hey, don't be afraid of getting roots into your answers at plus or minus root 2. Okay, new question. New type of question. Can we handle this? This equation has a tangent line at x equals 2 that is parallel to this line. What does A have to be for the case? Guys, it's the last page of your homework, right? These are where your quiz questions come from, the ones that everybody trip up on. So I hope we're not skipping this. This has a tangent line at x equals 2 that is parallel to this line. Okay, let's take this into account. Slope is 5. Cool. A is some sort of number. That's important. A is not a variable. A is a number. That means I get this if I take the derivative. These slopes at x equals 2 needs to equal 5. What do? Those slopes at x equals 2 has to equal that. Plug in 2, find A if it's equal to 5. If I plug in 2, I get 12A minus 5. When does that equal 5. Again, I plugged in 2 because my slopes at x equals 2. Here are my slopes at x equals 2. They have to equal 5. Add 5 divided by 12. I get 10/12, which is 5/6. Last two ones. Slopes at x equals 3 has to be parallel to this line. Use the slope formula to find this slope. Y2 minus y1, I go down. Well, let's go from 1 to 3. So I go up 12 as I go over 2. I like not using the slope formula. If you use the slope formula, you get -4 minus 8 over 1 minus 3, -12 over -2, positive 6. These slopes, b is just a number, so just leave it alone. I'm going to write 2bx. I'm going to bring the power down, use the power rule. These slopes at x equals 3 have to equal 6. 6b minus 2, this is this plugged in 3, has to equal 6. B equals 8/6, which is 4/3. It's not that hard. Last question. Got to figure out the slope of this line. Probably the easiest way is to solve for y. -2x plus, I don't really care. The slope is -2. I made a mistake. This should be -6x. The slope is positive 2. These slopes at 1 equal 2. (4c minus 1 equals 2). So he has to be 3/4. Okay, that's it. Some things to just remember. What is a derivative? It's a slope generator. Thank you, Newton, for discovering that there's equations for slopes. Great. Thank you for Newton for discovering the rules for these equations of slopes. That's great. You do a lot of algebra / arithmetic. You got some equations to solve. Here's a big mistake I see students make all the time. Make sure equations are set equal to 0 before factoring. You're going to have a couple test questions, I know, where you got to move everything onto one side before you factor. It all comes back to this: Newton's marriage of a limit and a slope formula. We kind of forget about this, but this is what helped us create our rule for our power rule, and we're going to have more rules for the rest of the unit that we're learning. Okay? Thanks. Messers out.